My voice is coming? Oh, thank you. So I was saying that what kind of substances can be taken as a pure substance, because this chapter name is what? This chapter name is matter around us pure, right? So we daily consume a number of things such as milk, ghee, sugar, water, common salt, garam masala, juices, etc. How do we know that all these things are pure or not? For a common man, pure actually means what? Having a no adulteration. But for a scientist, pure means that is it should contain only one kind of matter or particle. For example, if we examine sugar under microscope, we find that all the particles of sugar are same. Therefore, sugar is a pure substance. But when you see soil or garam masala under the microscope, you will see different kind of particles are there. If it is a mixture of different kind of particle, that substance cannot be considered as a pure substance. Yes, the ma'am, which is made up of only one substance, that will be considered as a pure substance. It means we can see all the matter around us is not pure. We can't say that every substance is pure. In fact, matter around us is of two types: pure substances and mixtures. So pure substances means what? Like pure substance is actually the smallest unit of matter. Like atoms, when we say atom, consider as a pure substance, right? And it will consider as a pure substance. Why? Because it contain one kind of atom, right? It means all the elements comes in that category. It means we can say that all the elements are pure substances because they contain one kind of atoms. We know the atoms are made up of protons, neutrons, electrons. We have studied that, and they keep their physical property and chemical property intact, right? One atom of the gold would still have properties of the gold. Even if you take the single atom of the gold, that will contain a property of the gold, that is malleability, ductility, then lustrous, right? So all are, so if I say elements are pure substance, right? So we can say there are two types of pure substances. One is the element and second is compound, right? If I say, if what should be the definition of a pure substance? A pure substance may also be defined as a material which contain only one kind of atoms or molecule, and these molecule can be, if these molecules are made up of only one kind of atoms, then the molecule of element, that will come under the category of elements. But if these are made up of different kind of atoms and chemically combined together in a fixed proportion by mass, it means that is what molecule of compound. Okay, so it means the elements as well as compound, they come under the category of what? Pure substances. A pure substance which is made up of only one kind of atom is called an element, while that which is made up of only one kind of molecule is known as compound. Suppose if I say one glass is having only H2O molecule and that is a distilled water, does not contain any kind of salt in it, it means that is a pure substance. If a glass of water, distilled water, contain only H2O molecule, only H2O molecule is there, it means it is a pure substance. So all the compounds, if one iron nail is made up of what? It is not rusted, it is prepared from the fresh iron nail. If it is a fresh iron nail, it contain only iron atom. It means all the elements are pure substances, right? So for example, if I say hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, carbon, these all are what? Actually, they are the pure substances. Now in this case, you can see these are the sample of the lead. All lead particles are what? They are the pure substances, right? Why? Because they are what? They are made up of single kind of atoms. If I say lead is also made up of single kind of atom. It is an element, right? If I say gold is also what? It is made up of single kind of atoms. So all elements, right, which is made up of one type of atom, and you know that these elements cannot be broken down into simpler substances either by physical or chemical means, because elements contain only single kind of atom. Even if you break iron nail, you will always get iron atom, you will never get something else. So elements cannot be broken down into simpler substances, and elements comes under the category of what? Pure substances. You know that there are 118 elements present in the periodic table, right? So we can see this is a periodic table. There are 118 elements, right? And out of these 118 elements, we know that 92 elements are what? 92 elements are natural elements, and 28 elements are what? 28 elements are man-made elements, right? So 92 elements are natural, right? And how many elements are there? 28 elements are what actually? 28 elements are what? Man-made elements. But who has given this theory of element? The Aristotle theory of air, water, fire, earth is made up of what? Elements, right? So let's see. Do you know that everything which is surrounded us, even in the space, the element is present everywhere? The elements alone or in combination makes up our body, because our body has a maximum concentration of what? Carbon, hydrogen and oxygen and nitrogen, right? And our whole world is made up of elements. Our sun is made up of element, right? In fact, entire universe is made up of elements, right? Entire universe is made up of element. Entire world is made up of element. But when we see the percentage in the earth crust of these elements, we can find that the most abundant element is oxygen. The most abundant element is what? Yes, class, tell me. Which one is the most abundant element? That is oxygen. That is 46.6%. So, oxygen is the most abundant element in the earth crust. It is the second most abundant is the silicon, that is 27.2%, and the third most abundant element is the metal, which is aluminium, that the percentage is 8.1. Likewise, this will be followed by then iron 5%, then calcium 3.6%, and the least abundant in the earth crust is hydrogen, because hydrogen is generally available in the diatomic molecule and it is a very light gas. So earth crust you will hardly find 0.1%. Titanium is 0.4%. Magnesium is 2.1. So most abundant element is what? Oxygen. How much percentage we can see? 46.6 percentage. Right? In this case, we can see 46.6%. Silicon means what? 27.2%. Aluminium 8.1%. So we can see how elements, when you try to find out in your body, you will find that in a body also most of the portion is oxygen, then carbon and hydrogen. So our body is also made up of three main elements, that is carbon, hydrogen, oxygen. And since we are also having protein in our body, nitrogen is also present, right? So who has given us this element periodic table? Who has arranged these elements in the periodic table form? Just now we saw the periodic table. So Mendeleev was the first person who has arranged 63 elements in the tabular form. So who is the father of periodic table? Who has arranged 63 elements in the periodic table? Dmitri Mendeleev. Understood? So what is periodic table? We know the periodic table shows all the known element in the universe, organizes the element by its chemical properties based on its valence electron and their chemical properties and based on their chemical formulas, right? So if I say periodic table, from the periodic table you get enough information about the element, because we can take a lot of information from the element. From the periodic table we can gather a lot of information regarding its chemical property, valency, right, valence electron. A great deal of information about an element can be gathered from its position from the periodic table. That understanding the organization and plan of periodic table will keep you obtain the basic information about 118 elements which are present in the modern periodic table. So how to read, whenever you want to read any element, how we can read these elements? we can read this element on the basis of what? Its atomic number. We can see periodic table always has this information about each and every element which is present. So carbon is what? Actually atomic number is 6. We can see symbol. It means it can give us 4 information about the element: atomic number, symbol of the element, its name, and atomic weight also. We know that atomic number of carbon is 6, symbol is C, and name is carbon, and then atomic number is 12. What is atomic number? We know that atomic number is the number of protons found in the nucleus of an atom or number of electrons surrounding the nucleus of an atom. Okay, this we'll study in detail afterwards. And what is symbol? We have already studied. Symbol is what? It is the shortest abbreviation of element name, right? Like carbon can be represented by C only. What is atomic mass? We can get the atomic mass from the total number of protons and neutrons which is present in the nucleus of an atom. So you can see from so many things we can gather a lot of information about any element regarding its mass, atomic number, weight, symbol. Right. So how do we find a number of proton, electron, neutron in element using the periodic table? We know that number of proton is equal to what? Atomic number. Number of electron is also equal to the atomic number, because number of protons and number of electrons are always remain same, because atoms are electrically neutral, so they must be having same number of protons and same number of electrons. And from the mass number, from the mass number, how we can get? So mass number means what? P plus N means protons plus neutron. So you can also come to know about how many number of neutrons are present in an element, right? So when you see the periodic table has 3 kind of element. So we should start learning about what kind of like we have to study about this metals, non-metal, metalloids, and what are their physical properties. In this chapter we need to understand. But if I ask you, how will you define an element? Like there are 3 types of element which we are going to study right now as per this chapter syllabus. One is what? Metals, non-metals, and metalloid, and they show some physical properties. So if I ask you, how will you define an element? You know that Robert Boyle was the first scientist who used the term element in 1661, and then Antoine Laurent Lavoisier in 1743. A French chemist was the first to give a useful definition of an element. What was the definition given by Antoine Lavoisier about element? An element is defined as the simplest form. It is the simplest form or basic form of a pure substance which can neither be broken nor build up from simpler substances. Just now I told you, it can never be broken down into simpler substances, right? So an element is defined as the simplest form or the basic form of a pure substance which can neither be broken into nor build up from simpler substance by any physical or chemical method. You use any physical method, use any chemical method, every time you will get the same kind of atom. This proves that elements are the purest form. Okay, understood? Okay, so it means if I say in terms of pure substance, how we can define? An element can be defined as a pure substance that contains only one kind of atoms, only one kind of atoms. So let's study physical properties of metal. What you can observe in this picture, you can see the nickel is there, rubidium is there, the gold is there, copper is there. You can see they are showing luster. They generally, whenever you see any metal, they are lustrous, right? And they are generally hard. They are solid at room temperature, right? Yes. A substance, Priyansh has written, a substance that cannot be broken down to simpler substance by chemical means is known as either by chemical or physical. You have to write both, either by physical or chemical method. You can't broke any, the element cannot be broken down into simpler substances because they contain only one kind of atoms. Even if you break iron nail, you will always get iron atom. You will never get anything else from iron nail, right? Or if you take any element, right? Even if you break oxygen molecule, you get oxygen atom only. You will never get if you break oxygen and you get nitrogen. No. It means the element cannot be broken down into simpler substances either by any method, either physical or chemical. Understood? So what we can see here, we know that in the modern periodic table, elements are metals are present on the which side? You can see group number 1, group number 2. All the alkali metals are present in the group number 1. Alkaline earth metals are present in what? In a group number 2. And then group number 13 also, you can see group number 3 to 12, all heavy metals are there, like gold, cobalt, nickel, iron, manganese, chromium. All heavy metals are present in the 3 to 12. You should just have information where are the position of the metals in the modern periodic table. So you will always find that metals are present. Metals are present where? Metals appear to the left of this dark zigzag line on the periodic table, and most metals are solid at room temperature. You have seen the previous pictures of the metals. You have seen most of the solids, most of the metals are solid at room temperature. This is the first property. Whenever you see any metal, you will see they are in a solid state and they are solid at room temperature, except mercury. Mercury is a liquid metal at room temperature. Mercury will be in the liquid state at room temperature, but most metals, they are solid at room temperature. You will see the few metals, they will melt in your palm, like gallium and cesium. They have very low melting point. After absorbing the temperature from your skin, they will melt, right? So we know that most metals are solid at room temperature except mercury. Mercury is a liquid at room temperature. And second thing, some metals can melt and they convert into liquid in your palm. That is what actually gallium and cesium. So we have understood. Then the next is what? You can see that metals have luster. This means metals are shiny. We can see metals are shiny. You can see the cesium, you can see the lot of luster, gold, platinum, silver, and that's why the gold, platinum, silver, they are using for making jewelry. These metals are the noble metals, and because of their luster, because of their shine, they are being used for making jewelry. Why? Because they are lustrous. Okay, so metals have luster. This means they are shiny, right? Then the second property, you will see that metals are ductile, right? So metal can be drawn into thin wires, right? And then the most ductile metals are gold and silver. When you take a 1 gram of gold, do you know how much length of wire can be produced from 1 gram of gold? You know that from 1 gram of gold you can make 2 kilometer thin wire. The gold is the most ductile metal. The second most ductile is silver. So gold and silver both are ductile. What is ductile means? Ability to drawn into thin wires. The metals have ability to drawn into thin wires, but non-metals can't have this ability because they are very soft and brittle. When you try to hammer or when you try to draw them into thin wires, you will not be able to that. Why? Because they are very soft. Then we can see metals are malleable. Why? What do you understand by malleable? Because malleability means what? Ability to beaten down into thin sheet. You can see this is an example of aluminium foil. Means metals can be hammered into thin sheets. So if you keep on hammering any metal, they will convert into thin sheet. That's why you can see lot of iron sheds are there. Why? Because of which property? Because of malleability. Once again, the most malleable metal will be gold and silver. These two will be the most malleable metal, gold and silver. Once again, gold and silver will be the most malleable metal. Then we can see that metals have high melting point. Why they have high melting point? You can see we are using cooking utensils for making food. Why the cooking utensils are made up of metals? Because they have very high melting point. When you cook food, they are not going to melt, right? So that's why utensils are made up of what? Metals. Specifically, why? Because they have high melting point. And why they have high melting point? Because metals are very dense. It means they have high density. They possess high density. And that's why metals are very dense. You know the most heaviest metal is what? The most heaviest metal is osmium. The osmium is the most heaviest metal. Understood? So we know that metals have high density. Why metals have high density? Because they are dense. They have, and that's why they have high melting and boiling point. And the osmium is the most heaviest metal, right? Then we can see they are the good conductor of heat and electricity. They are good conductor of heat and electricity. They can conduct better, right? So when you leave a spoon, how we can find out why they are good conductor of heat? So when you leave a spoon in a cup of hot drink, you have a hot milk or hot coffee, the bit poking out of the drink gets hot. Why? Because of the conduction. Metals are the best conductor of heat. This is because, why? Because the electrons in the metal move more freely than the non-metals, allowing the heat energy to travel across the metal. For example, when the spoon touches the hot drink, the heat from the drink excites the electron which is present in the metal, and then electron transfer this heat energy up to the spoon. That's why the spoon will also become what? The spoon will also become hot. When you touch the spoon, spoon will become hot, right? So why the food is cooked in the container, this because they are the good conductor. Why the food is cooked in the metallic container? Because they are the good conductor of the heat. We can't cook food in a container which cannot conduct heat. That's why metals are preferred to use as utensils. Why? Because they are the good conductor of heat. And the best conductor of heat is silver and copper. These two metals are best conductor of heat. Understood? Now the another physical property, the metals are good conductor of electricity. Just now we have discussed copper, silver, gold are good electrical conductor, right? And silver is the most, you can say the best conductor of electricity, silver. Since silver is very costly, so we can't make a wire out of silver everywhere. So that's why copper is preferred, right? So copper, silver, gold, all three are comes under what? Good conductor of electricity. In a conductor, electric current can flow freely because we know that metal possesses free electron, and for conduction of electricity, either they should have free electron or ions. Now in metals have clouds of free electrons. Due to the presence of free electron, they conduct electricity because they can carry a charge easily. Then a chemical property of metal in its reaction with oxygen is what? You know that they are going to produce rust. We are not going to study the chemical properties, but generally the metals are rust. Metal undergoes corrosion and rust. Rust means specifically we are talking about rusting of iron. Iron undergoes rusting because you can see one flaky reddish brown color substance can be seen, right? Reddish brown flaky substance can be seen on the iron when it is exposed to the moisture or air, right? Then when we talk about non-metals, right? This is sulfur is a non-metal, right? Nitrogen is a non-metal, selenium is metalloid, and bromine is a liquid non-metal. We know that, right? Now we can see where is the position of the non-metals. Now we can see the non-metals occurs to the right of the zigzag pattern of this. We can see there is the black, the green, this green color portion. So the non-metals are present on which side? The right side of the dark zigzag pattern, right? Right, on the periodic table. So hydrogen is, although hydrogen also belongs to non-metal, since it has a one atomic number, one valence electron, that's why it is kept in the group number 1 of periodic table along with the alkali metal. But hydrogen also belongs to non-metal. So many non-metals are in a gaseous state at room temperature. Some are in a solid state also, like iodine is a violet color solid, sulfur is a yellow color solid, phosphorus either white or red color solid, right? And the gases means nitrogen gas, oxygen gas, chlorine gas, and bromine is a liquid non-metal. We know that. So bromine is a liquid non-metal. So non-metal does not have luster. They are dull, right? So they are not luster. We have seen in case of metals, they are lustrous, but non-metals are non-lustrous. Understood or not understood, beta? Nobody is giving any response. Priyansh, Devansh, Vaibhav, Shradul, are you getting my point or not? Yes or no? Understood or not understood? Yes, class. Priyansh, Vaibhav, no comments. So non-metals do not have luster, they are dull, right? And they are very brittle. The brittle means non-metals are brittle. They can break easily. This means non-metals are non-ductile, non-malleable. They are non-ductile, non-malleable. They cannot be beaten down into thin sheet. It means they are not going to show the malleability. They cannot be drawn into thin wires. Why? Because they are very soft, brittle. They can be broke very easily, right? Since they are soft, why they are soft? Because they have less density. Since they have less density, everything is interconnected better. So since they have a less density, that's why they'll be having a low melting and boiling point, and they'll not be able to conduct electricity since they have less density. It means particles are little bit far from each other, so they cannot conduct heat from one end to another. So they are the poor conductor of heat and electricity. Understood? So non-metals are brittle. So why? Because they break easily. This means non-metals are non-ductile and non-malleable. Understood? So non-metals, I told you why they are non-ductile, because they are very brittle. Why they are brittle? Because they have low density. You can see, can you convert this into the sheet? No. Even if you hammer, this will be broke down into small powder. Okay, so non-metals have low density, and that's why they have low melting point, and that is why they are the poor conductor of heat and electricity. That's why they are poor conductor of heat and electricity. Why? Because they have very low melting point. They have less density. Less density means particles are little bit far from each other, right? It means they are not going to conduct heat and electricity. That's why they are poor conductor of heat and electricity. Understood? Now the left metalloids. What are metalloids? Like germanium, arsenic, these are metalloid. Polonium, right? So silicon, these all are what? Metalloids, right? So metalloids will have, where is the position of metalloids? The metalloids can be found in the clustered around the dark zigzag. Boron, silicon, right? Then arsenic, tellurium, polonium, these all are what? These all are what? They separates this zigzag pattern that separate metals and non-metals, right? And it means they are present in between the metals and non-metal in the modern periodic table, right? And they possess the properties of both metals as well as non-metals. Metalloids, they have properties of both. That's why they are in between. You can see this boron is very shiny. Otherwise non-metals are non-lustrous, right? And but these are what? These are the metalloid. They possess the property, but this is boron is very soft and brittle. It means it is a property of what? Non-metal, right? So it metalloids mean they possess the properties of both metals as well as non-metal. And some metals are solid, that can be shiny also or dull also, depends. It means some metalloids can be shiny and some metalloids can be dull. It means they are showing the properties of both. They are showing antimony, you can see it is very shiny, and when you compare with the silicon, it is dull. It means they can be shiny or they can be dull also. Now we can see they conduct electricity and heat better than the non-metal, but not better than metals. Means they are in between. So they can also conduct heat and electricity, but they can conduct heat and electricity better than non-metal, but not better than metals, because metals are the best conductor of heat and electricity. Non-metals are poor conductor of heat and electricity. On the other hand, when you see metalloids, they can also conduct heat and electricity, but not better than metalloids. Sorry, metals. Now we can see the silicon. Metalloids are malleable and ductile. The silicon can be, you can see it can be changed into which sheet? The malleability. Silicon can be shown. Now I hope you have understood this, and now I would like to show you something else. So let's revise some properties. So let's revise some properties. We'll do the quick revision of this portion. so that we should complete element and then the compound will be left behind. In the next class we'll do that, right? So we have seen there are three types of elements, right? We can see that metals are malleable. Just now we have understood what are the main properties of metals. Metals are malleable, metals are ductile, they are good conductor of heat and electricity, metals are lustrous, metals are hard, and they have high tensile strength. What do you understand by high tensile strength? Tensile strength means ability to hold heavy object. You must have seen all bridge, the crane. The hook of the crane is made up of what? Metals. Why? Because they have to lift heavy object. Only metals can do that. Why? Because metals are very hard and strong. Metals are strong, but non-metals are very soft, so they will be having very low tensile strength. Non-metals are having very low tensile strength, but metals are having very high tensile strength, and that's why the most of the things, like you can see, if you want to hold a very heavy object, we will always use a metallic wire, right? Now we can see the metals are solid at room temperature except mercury. We can see except mercury. So what is the exception? We know that exception is mercury, right? And then they have a high density. We know that why they have high density. The heaviest metal which we have discussed is what? The osmium. The most heavy metal is what? Osmium, right? And metals are sonorous except lead. Lead is non-sonorous. All metals are sonorous. Sonorous means what? When they hit with a heavy object, they are going to produce sound. Okay, so when they hit with a heavy object, they are going to produce sound, right? So metals are sonorous except lead, right? Now they have very few colors. Metals have only few colors. You can see either silverish color. Just now I have shown you so many metals. You have seen the silverish color was the most common one. So either they will have silverish or grayish color metals, or you can see in the gold, you can see yellow color is there, in the copper brownish color is there. But one thing was common in all the metals, they are lustrous, right? And they show only few colors, right? Few color means silverish or grayish, and yellow can be seen in case of what? Yellow can be seen in case of gold. Silverish is the most of the metals are silverish, and they have high melting and boiling point. Why they have high melting and boiling point? Because they have high density. And that's why, because of, since they have high density, they are the good conductor of heat and electricity, because particles are very very close to each other. So they, one atom can transfer the heat to another atom, then another atom will transfer the heat to a third atom. Likewise they can conduct heat, and like since they have possess free electrons, so they can conduct electricity also. Understood? Likewise, when you see the non-metals, non-metals are non-ductile, they are non-malleable. Why they are non-ductile, non-malleable? They are soft. Non-metals are soft, and they are poor conductor of heat and electricity, and they are non-lustrous also. They are generally dull. So non-lustrous means what? They are dull, right? And they are generally soft. Soft means brittle. They can be easily break. So that's why they are non-malleable, non-ductile. They cannot be beaten down into thin sheet. Why? Because they are very soft. When you beaten down to thin sheet, what is going to happen? They can break easily. They are not strong. Why they are not strong? Because they have less density. Okay, and because they have less density, that's why they have low melting and boiling point. Okay, they have many color. Do you know that they have many color? We can see iodine has which color? What is the color of the iodine? We can see with iodine violet color, right? We can see in case of sulfur which color can be seen? Sulfur has a yellow color, right? Sulfur has yellow color, right? Then when we see this thing graphite, right? Graphite has a grayish color, right? So it has a gray color. Then when you see this thing chlorine, what is the color of chlorine? Greenish yellow color gas, it is greenish yellow color gas, right? When you see bromine, what is the color of bromine? That is brown. So we can see the variety of different color in case of non-metals, right? Now the next is what? Next is what are we have understood about one portion of the pure substance, that is element, and the next is compounds. If I say what are compounds, so how will you define what are compounds? A compound is defined if I say what are compounds, right? A compound is defined as a pure substance made up of two or more elements chemically combined together in a fixed proportion by mass, right? If I say H2O, can we say it is a compound? Yes, they have combined with each other in a fixed proportion by mass, that is 2:1. Okay, so let me show you some compound pictures. So you can see what are compounds. What are compounds? We can see the compounds are what? So compounds are what? Actually, they are also pure substances. Why? Because they are composed of the multiple types of elements, two or more, and they are chemically bonded to each other. And compounds cannot be broken down by the physical method we have discussed from the beginning. So compounds cannot be broken down into the simpler substances by physical means. They can be broken down only by using chemical reaction. Suppose if you want to separate water, right, and if you want to separate hydrogen and oxygen in the water, you cannot separate hydrogen and oxygen, right? Now second thing, whenever you see the compound, there will be definite composition with element ratios indicated by subscript H2O. For example, if it is water, for example, if it is calcium carbonate, then it is CaCO3. It means 1:1:3 ratio will be there, right? And then compound will always have very different properties from the element which make them up. For example, if we are making water, we know that hydrogen is present in the water, but when you see its individual property as an element, when you see its property, it is highly combustible gas. And oxygen is what? Oxygen is supporter of combustion, right? But when these two elements combine together to form water, or water, where we use the water to extinguish fire. So we can see that whenever compound will be formed, compound will show entirely different properties from its constituent particles. Understood? Now you can see in this example only, sodium is highly reactive metal. It can start burning in the presence of air as well as water. So that's why we need to keep sodium and potassium under kerosene oil. Why we need to keep? Because in that case it should not come in the contact with the oxygen of the air. Understood? So it should not come in the contact with the oxygen of the air. And whereas chlorine is a highly poisonous gas, it is a poisonous gas, and that's why you can see these two men, they are wearing mask. Why they are wearing masks? In the presence of chlorine gas, what is going to happen? It is a poisonous, so they don't want to inhale chlorine gas. So you can see their individual properties. Sodium is highly combustible. It will catches fire in the presence of water or air. On the other hand, you can see the chlorine is a poisonous gas, but when these two elements combine together to form sodium chloride, so they are going to form what? They are going to form sodium chloride, which we eat every day. We don't have to preserve sodium chloride under the kerosene oil. Why? Because now the sodium chloride is showing entirely different properties from its constituent particles. We can see sodium was showing different properties, chlorine was showing different properties. When these are combined together, you can see that sodium chloride will have entirely different. It is non-combustible. It is not going to catch fire in the presence of what? It is not poisonous. We are eating every day in the food. So this point can prove that the compound will have entirely different properties. And now in the next class we'll study mixtures, and then we can see how many types of mixtures are possible. There could be two types of mixture, element plus element mixture, like iron and sulfur both are element, right? Compound plus compound, suppose when you dissolve water in the this thing, when you dissolve sodium chloride in the water, you get a compound plus compound mixture, right? Element plus compound, it means you are dissolving sulfur in the carbon disulfide solution, you get a mixture. So mixture is something that can be broken down into simpler material using physical method, but in compounds and elements, these cannot be separated into the simpler substances by using physical method, not in case of element or not in case of compound. Only mixture can be broken down into simpler material by using physical method. I'm giving you a very simple example. If I give you this iron and sulfur, what is going to happen? Not in this case. Next class I will show you. No, it is not there in this slide. So we know that there are two types of mixture. Homogeneous. These parts are distributed evenly, like salt, water, syrup, air, brass. Brass is actually what? It is a alloy, right? And then there is a homogeneous mixture generally of liquid is what? Actually they are known as solutions, right? And homogeneous mixture of metallic atoms are known as alloy. I'm running so that I wanted that you should complete this. Heterogeneous means what? The parts which are distributed unevenly, right? Then water and oil mixture is what? Heterogeneous mixture. Here we can see the separation boundaries. The previous case we can't see any separation boundaries. When you can't see any separation boundaries between two constituent particles, that makes a homogeneous. But where you can easily see the separation boundaries, that makes heterogeneous mixtures. So we have learned that the properties of compounds are totally different from the properties of the element that make them. But when you see any mixture, the properties of mixture are related to the properties of the substance that makes them, right? It means they possess the same properties. So now we can see how we can distribute matter. Now if it can be physically separated, if yes, so it is more, it means what? It is an impure substance, that is a mixture. If it cannot be physically separated, it means it's a pure substance, right? Then it is a pure substance. And then if the mixture has a uniform composition, then the homogeneous mixture, like solution or alloys. And if it is not, if the composition is not uniform, then heterogeneous mixture. Now the how we can further divide pure substances. If it can be chemically decomposed, then it is compound. If it cannot be chemically decomposed, then it is an element. So how we classify this matter? We can classify and we can differentiate into this. Now in the next class, we will do the separation method, right? And then we'll compare also. We'll try to discuss all the NCERT questions. I hope you have understood the concept behind this. In the next class, we'll continue and I will try to complete most of the portion of atom and molecule also as per the plan. Okay. So thank you very much, beta. I'm going to end my class.